Okay, let's dive into section 9.2 on exponential and natural log functions. So we just got over the intro to logs, and we spent time writing from a logarithmic function into exponential function and exponential function back into log form. And so now we are just going to kind of work with doing the same thing, but specifically with natural logs. And in this box we have the definition of natural log. F of x equals log base e of a, which in essence is going to be rewritten from this point on. Instead of log base e, these two combine to just become the letters ln, which represent the words natural log. Okay, so there's an e subscript understood to be there, but we just never rewrite it. Okay, we just pretty much condensed the log e into ln. So just like, I think I've mentioned this before, if I had written something like this of log of 25, it's understood that this subscript is understood to be a 10. It's called the common log. So you will not see, if ever, something written like this, log base 10 of 25. It's understood to be blank and interpreted as a 10 if it's written, let me erase this here, like that. Okay? So when I see something like ln of 13, I know if I am asked what is the base, that my base is actually an e. Okay? There's an e there. So just bringing that to your attention. And by the way, e is a number. Okay? It's known as the Euler's constant, and it can be found on your calculator if you have a TI-84. Right over here above the ln button is the e. So if I do second ln, you will see it will pop up like this, e to the what power? And we're just talking about e to the first power. Euler's constant is equal to approximately 2.72. Just another important number for you to know, just as you already know that pi equals 3.14. Okay? So that's the Euler's constant. Okay? So back to rewriting. Whenever you have 2.72, or what we will call it from now on, e to the x power, or 2.72 to the x power equals some number, that is the same way as writing ln base e of a equals x, but we will never read it as ln e of a equals x. We read it as natural log of a equals x. Okay, so let's practice rewriting. Okay. Oh, I guess I should discuss these properties. We've talked about it before. When the base and the number are identical, that they will always equal 1. So just in the same manner as log base 5 of 5 is equal to 1, or log base 12 of 12 is equal to 1, log base e of e is equal to 1. Okay? We talked about this, well, we will talk about it in 9.3 some more, but just so you'll know, this can be rewritten. Whenever you have a power, you can move it to the front as a coefficient, and x times ln e, well, we already know ln e is 1, right? And x times 1 is just going to give you itself. And notice that e to the ln e of x, the e here is identical to the e here. Those disappear. I like to do my upside down happy face. That gives you an x. Alright? So, simple. Let's simplify. ln e plus ln e, well, we know that's a 1. We know that's a 1. So it's a 2. Some students I've seen do it this way. ln e plus ln e makes 2 ln e's, but 2 times 1 is still going to give me a 2. So I don't know which way you saw it, visualized it. Either way works the same way. Okay? ln e to the 4th power plus ln e to the 5th power. We're going to move those exponents to become coefficients. Well, 4 ln e plus 5 ln e is 4 times 1 and 5 times 1. Okay, let's rewrite. You don't have to do it this long way, but I'm going to show you how this is going to equal this, okay? So if we use the word log instead, okay, so if I said log, the base of this problem was e of the number equals x. Well, log e we already established is ln 12 equals x. So if you can go from here to there, I'm totally fine with that, but I just wanted to show you this step in case some of you prefer using log and helping you transition into ln, okay? We cannot rewrite this into log form because there's a coefficient. Always get rid of the coefficients. We want coefficients of 1. So e to the x power equals 10. Again, you can write that as log base e of 10 equals x, or merely just say ln of 10 equals x, or x equals ln 10. I don't care what order you write it. That one, ln of 72 equals x. Alright, let's solve for this one over here. Okay, now this time, these here have log form. These here were all in exponential form. Notice there was not any ln in the original problem, so these were exponential form. So let's go the reverse manner. Well, if it's written in log form, what did we do last section in 9.1? We always rewrote it in the opposite form. What's the base? It's an e to the 2nd power equals 3 to the x. The x is almost isolated. I'm going to divide by 3 on both sides to get that x all alone. And so I'm done. E squared over 3 is my x value. I need to solve for x. Let's move the 2 to the other side by subtracting. ln x equals 8, so it's in logarithmic style. Write it in exponential. E to the 8th power equals x. Let's get rid of the 3 on both sides. Not on both sides, on the left-hand side. Simplify to get ln x equals 3. X is not isolated, so let's rewrite it. E to the 3 equals x. Okay, so just like you did with regular logs, okay, in 9.1 you'll do the same thing in this section. You will always rewrite into the opposite section, into opposite form in order to isolate your x. Alright, let me raise this up a little bit more so that we can capture the entire sentence on example 9. So example 9, the population of bunnies is growing exponentially. At the beginning of the first month, there are 60 bunnies, and after 6 months, there are 224. The exponential population growth of these bunnies can be modeled by using y equals a times e to the bt, where a is the initial amount, y the population after t months have passed, e is our Euler's constant, the 2.72. The growth ratio is part of the exponent that's being multiplied by t, which is the number of months. So the first thing they want us to do is calculate the growth ratio. So they want us to find b. The growth ratio is b. So, well, let's go ahead and use our equation to help us start out. Okay, so we were given y equals a e to the bt power. In this story problem, we were given 60 bunnies. That's what they started out with. After 6 months, there was a total of 224 bunnies. Here are the descriptions. So let's fill them out. Not Y, what am I talking about? Y represents the initial amount. The initial amount were the 60 bunnies. So I'm going to put a Y right here. My Y were my, you don't even see what I circled. Y were my 60 bunnies. That's what we started out with. Okay? So let's come over here and substitute. So for Y, I'm going to put my 60 bunnies. Wow. Take that back. Y is what we started out with. That's A for the initial amount. Y is not the initial amount. So sorry. Let's put that back again. 60 is my A. Y stands for the population after a certain amount of time has passed, and that was 224. So here is my Y, and let's fix this over here and replace that with an A for initial amount. My apologies. Okay, so here our ending amount is 224 equals 60 times E to the B. We don't know what that is. And T was the number of months, which in this case it's a 6. So let's solve for B. So what we need to do is get rid of our coefficient. So we need to divide both sides by 60. Okay, I'll move this over a little bit. 224 divided by 60, 224 divided by 60 gave us a long repetitive decimal, which I'm just going to convert into a fraction.
Mom?
Okay, so the 56/15ths, we're going to write it down here after doing the math fraction. The E comes along and raise it to the B6 power, which is going to be 6 times B. 6 times, I'm going to put a capital B here because that B looks so much like a 6. Okay? So please know that that's the same B. Okay, so we need to solve for B. Okay? We know logarithms to be able to solve for B. Okay, so we need to take the ln of, what am I writing? Log base E of this number, 56/15ths. And I know that that will be equal to 6 times B. Okay, or the capital B. I guess I'm reverting back to it. Okay, the 6 times the B. Let's write capital B since it's easier. Alright, but what do I need to do to solve for B? Well, I need to take my ln of 56 over 15, and I'm going to divide it by 6 because I needed to have divided on both sides to get that B by itself. So calculate the growth ratio. Okay, well, I'm going to take the ln of this answer that I originally got, and it's supposed to be divided by 6, and so 0.219550 and so forth is my growth ratio. Since I'm going to round it to 3 decimal places, I'm going to put 0.220 because of that 5. So B, I guess I can write lowercase b and go back to what it was in the story problem, is approximately equal to 0.220. So in the next section, they're asking us to write the model for growth. Well, the model is that equation. So y equals my A. My A was the initial amount. E to the BT, my B is this number, 0.220t. Notice that when you write the model, you never substitute for domain and range. Okay? Never substitute your domain and range values when it comes to writing out your model, okay? Okay, and then let's move over here to using our model. In part C, they're asking you how many months before there are 600 bunnies. So we're looking for T. How many months means find T, okay? Find T. So if I need to find T, that means that is the only unknown I should have. And right now in my model, I have 2 unknowns. That means I have to put a number in there. That number is the population after T months have passed, and they actually gave that to me here. So 600 equals 60 e to the 0.220t. Again, it's part of being the exponent. Do your regular rewriting it in log form. But before doing that, always a coefficient of 1 is what we always need, okay? So make sure you get rid of that. That simplifies to a 10 equals e to the 0.220t. And rewrite it in log form. The log of 10 equals 0.220t. I need to divide both sides. Now I can say T equals, let's do some, I'm trying to let you guys see what I'm typing. I guess I'll put on this side. Right about there. Okay. ln of 10 divided by 0.220, and I get how many months before there are 600 bunnies, and I'm going to put approximately T. Will take about, rounding it to 10.5 months. 10.5 months. And that is our lesson for the day. Hope that clarifies any issues you're having with 9.2. Okay?